One, two, one, two, one, two, one, two, one, two. Woo! Hello, guys, and welcome back to this one. I am excited for this one. Brand new week. We're wilding, we're vibing, we're thanking God, we're thanking Jesus. Okay, so we're going to resume off the part two. Although I believe this might still have another one, another part, because I don't want the videos to be too long. This is secular Q. So we already handled the brute force, and we saw that Enqueue had O of 1 and Dequeue had O of n. So basically we are now trying to look at, you know, um, how to make the queue as well O of n, and the trick is basically a circular queue. So I'm just going to start off by introducing us to what a circular queue is, and basically kind of its properties. So it has a counter, meaning that okay, it has a counter, it has a capacity, so it means that there's an amount of values that it could hold, and then it has a front pointer and a back and a rear pointer, and we could see it's instantiated with -1 and -1. So it is not basically pointing at any index at the time, right? So let's just see a graphical illustration of this. Now we could see here that we have a circular queue over here and one that is a linear queue. Now, what was the problem with a circular queue, the linear queue? A linear queue, when we pass in values from here, the first in, last out idea, the first in, first out idea rather. So we pass in 0 from here, and now we want to pop 0 out. Now, when we pop 0 out, if this is the index of 1, right? All these guys will have to shift. Reason why we had the queue being O of n. Now, with a circular queue, that's how we solve the problem now, because we now have the circular queue and then pointers, and as we go through the whole lesson you get to see how ingenious this solution is. So let's get into it. Now let's look at Enqueue again. It was O of 1 in the last time, but because we've changed our structure now, we have to now look at how we handle it here. Now we say if self.count, that's basically the count of our list, right, is equal to the length of the array. Basically what it's trying to say is that if we get to the maximum or the max, because you could see from my illustration here we had just 6 slots, 0, 1, 2, 3, 4, 5. So these 6 slots, if they get exceeded, is what this line is saying, that we should resize. Now we're going to still get to resize subsequently, but just to give us an idea of what that is basically increasing the capacity of the queue. So we could see much more of a resized what's it called, a resized cyclic queue right here. Now so we say if that's not the case, what do we do? Let that if count is equals to 0, right? What that means is that if the count is 0, and that means we don't have anything on our queue as at that time, that we want to point our self.front and our self.rear to 0. So basically what that means is that this is our self.front, right? Let me point this away for now. Now this is our self.front, and before they were pointing to -1, remember? You could see here. So imagine if I have -1 here, -1 somewhere over here, -1, and these two guys were initially pointing to it, right? And now we want to change that, and we want to make it start pointing to 0, because initially they were pointing to -1. Now we want to point to that axis. Now let's take it that this guy does not exist yet, right? We'll take it that this is empty. This list, the entire list is empty, right? Right. Now, so it is 0 and it is empty, right? And then we point to the first index, which is the index of 0, right? And then when we point to that, we now say self.front is equals to self.rear, right? We first point the two of them to each other, and then we point them to 0, which is the index of the first guy. And then we skip the else. But what if we are not handling the first one is the question. Now the second question is in the case where we have a populated queue, right? Just as we had here before, right? And we want to add one more. What do we do? That's what the else handles, right? So what do? We say self.array, right? Because we know we are enqueuing, we are adding. So our array, so before we explain the first bit, our array was at the array actually. So the front is the beginning part, and the array is the latter part, right? We say self.array is equals to self.array plus 1 modulo length of the list. Now, the length of this list is 6 because when we've counted it before, we saw that it's 6. Now, we say array plus 1, right? So 4 plus 1 is what? 5. Divided by or modulo 6, that is still 5 because modulo is basically remainder. So when you divide 5 by 6, what you get is still 5, right? Because that's the remainder rather, right? So we know that the array begins to point at this guy over here, right? Begins to point at him saying, oh, this is now the array, right? And then it goes ahead to say, well, self.array should be pointing to data. Sorry, array. So yeah, self.array is how do you say it? Index at self.array, right? So basically, it's trying to call that. It's trying to look at the pointer, pointing at the last index, right? This guy, and then it's pointing the data that's coming in or that is being enqueued into it, and then we go ahead to say self.count plus equals to 1. That we have just added a value, so it's natural that we increase it, and then we go ahead also to return the value that we have just um, added to show success in a sense, right? So basically here, let's say 5 was what we wanted to add. We've added 5. Now one might ask, why all these shenanigans just to add one value, right? Why didn't you just do 4 plus 1 to get 5? Why did you have to do modulo 6? Now that's the beauty of cyclic a circular queue, or basically our way of implementation using Python. So because we know we are still making use of a regular list over here, right? So it's still a regular list. It's not just as if we hit something that became circular. So because we are still using a normal list now, we want a situation where if I were to add something else to this list, so let me say this list is um this front, right, had started from here, something like that. So because we enqueue from the front, right, uh, or from the array, because we enqueue from the array and dequeue from the front. So let's say we've dequeued 0, we've dequeued 1, and our front right now is pointing to 2, right? And then we want to enqueue something else because obviously you know that here this will be a it will be removed, this will be removed, and then we will have 5 over here, and then we want to add something else. So the next enqueuing will be in the first, it will be at the index of 0. Now, how do we do that? So let's say we say 5 plus 1, just with our formula over here. We say 5 plus 1, which is 6, right? When you do modulo 6 with 6, what do you get? You get 0. So you see that it points us back here. And the same thing when we move on. So that's basically what it's just trying to do. It's just a formula that connects the array of an ideal array to its head, basically. And yeah, that's basically that for that.